We must move. We will defeat the Metallics. good shot. Nice shot. Very nice. Nice shot, my friend. Nice shot. Very good shot. Nice shooting.
Oh wait, never mind, because I'm gonna get a brand new 5-star for beating that boss! I am the storm that is approach. Pog! Tighnari is cracked. Double Tighnari on the standard banner is more cracked. Tighnari is like one of the best characters on that banner. And that was literally the last one that I got. What? Hello? Tighnari. Dude, that's back-to-back Bessie.
Error handling is a huge part of writing Go code. Read a file, it spits out an error. Set up a database, it returns another error. Bring up a server, it gives us back, again, an error. Additionally, error handling remains to be one of the most controversial language design decisions the Go team has ever made to date. So it's extremely important for you to learn and understand the best practices and advanced tips in today's video so you can write proper Go code when it comes to error handling. Pay close attention in today's video. Before we get started, make sure to get your free Golang cheat sheets at Start with the basics. When we are performing some operations that may or may not succeed, we will return an optional error, meaning the error can either be nil or something concrete. And to create this concrete error, we will use the new function in the errors package. If we go to the implementation of the new function, we can see that it is creating an instance of this error string struct, which contains the error string, the error message, as one of its fields, or the only field. When we get the error back from the uncertain operation, we will need to check if the error is equal to nil. If it's not, then we need additional logic to handle the error. I often get asked, especially from Go beginners, whether checking the error is not nil is the only way to handle errors in Go, because it seems pretty damn repetitive. There's gotta be a better way to handle errors in Go, right? Am I making some sort of a newbie mistake here? Unfortunately, at least at the time of this recording, checking if the error return is not equal to nil is the only recommended way to handle errors in Go. On the bright side, there has been quite a few very promising proposals in progress, such as this one right here, adding a new tried function in order to make the error handling logic a lot more user-friendly. I've actually done a video going through each one of these proposals, so make sure to check out that video if you haven't already. The next tip, use the error interface. Using the same example here, this some uncertain operation function is returning an error, and this error is an interface that has one single method to be implemented. And this errors.new function is returning an instance of a struct that is implementing the error interface method. This means that we can create our own custom error types as long as this custom error types or error struct that we are creating is also implementing the error interface method. The next tip for handling errors in Go is to return errors as early as possible. Here we have two examples side by side to demonstrate the differences. The example on the left returns the errors as soon as possible versus not so much for the example on the right. The first example returns the errors as soon as they're discovered, resulting in much more uniform and consistent if statement blocks, compared to the nested if statements in addition to the else clauses. In general, returning as early as possible is a coding style also known as early returns. So if you're interested into the pros and cons a little bit more in detail, I highly recommend searching for the term early returns. Next, let's talk about the is, as, and unwrapped functions. Let's say that we have a two error struct and a function already implemented. A custom named error struct implementing the error and unwrap interface methods. Then a custom Dojo error struct implementing the same methods. Lastly, a function that helps us wrap an error using the font errorf function. If we create a few errors using these custom error structs, then we will be able to use the is function in the errors package to determine if two errors are of the same type. Use the as function to determine if two errors are of the same type before they're wrapped. And lastly, use the unwrap function to unwrap a wrapped error. The next tip for error handling in Go is to reuse common errors already instantiated. For example, if you have multiple places in your code that returns pretty much the exact same error, then you should consider creating a package level or even global common error variable, and then replace the individual instantiations with this common error variable. This enhances the readability and the maintainability of your code as well as saving some runtime computer memory. The next tip we have is utilizing request scoped data. Here we have an example. We can create a context instance on one process and attach some request-specific information such as a request ID to that context. If we were to somehow create a different process, such as using a Go routine or making some API calls, then we would be able to handle errors utilizing the request scope data attached to the context, even though the error may occur on a separate process. So these are some of the best practices and tips that you should follow as well when you are handling errors in Go. Now I may have skimmed through or
Gentlemen, it's Ryan here, and today I want to talk about generics in Golang. Generics is a feature that allows you to write your code in a way where you don't have to repeat the same code over and over again. Generics has been a part of many other languages for years now, C++, Java, Rust, and so on, but it's rather new for Golang, and it's probably the biggest update to the Go language pretty much ever. It just came out recently in the 1.18 release in 2022. So again, generics in Golang, that's what we're going to go over today, and let's go ahead and jump into it. So let's say you have a function called add, and it takes in two parameters. One is a, which is an int. The other one is b, which is also an int. And in the end, we're going to return an int. And we're going to say return a plus b. As a sanity check, let's just run this. Print the result, and yeah, 3, just as we expected. So this is great and all. The only problem is, what if we want to pass in something other than an int? What if we change this to 1.1 and 2.2? We want these to be floating point numbers. Then what happens? Okay, yes, as expected, it's telling us, hey, this is a float. You're trying to pass it as an int argument. That doesn't work. And so what we can do here is, well, we can say, you know what, let's make this add int, and then make this another function called add float. And then we can change all these to float 64 and just say, okay, add float. And sure, this works as expected, got a floating point error there. But the problem is that we have multiple versions of this same logic, right? It doesn't make sense. For all of these, we're doing a plus b, so we should be able to reuse this logic for different types, right? Well, now with generics, we can do that. So let's go back to our previous logic. So first of all, make sure you're using Go 1.18 or later, because this will not work on the older versions of Golang. So having said that, what we want to do is add some brackets here, say t, that's our new type, and we're going to say int or float 64, and instead of int, we're going to say t, t, and t. Basically, we just turn this into a generic function now. It's our IDE is not complaining, at least. So we're passing in integers. Let's test it, make sure that works. Yep. And let's turn these into floating point numbers, make sure that works. And yep, as expected. This is cool, but the problem is there's a lot of different types of ints, right? There's int, int 8, 16, 32, 64. So am I really going to go here and do int 8, int 16, blah, 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 float 32, yada, yada, yada. No, this is just a little bit too verbose. So the first thing I can do is I can move this out, create something called num, and then we can say type num interface, blah, blah, blah. And what we just did is create our own data type called num, and that's what t is. And so saying the parameters and return type can be any one of these that are part of that interface. If we run it, yep, works as we expect it to. So still, it's a little bit verbose, kind of not the way we want to do things, right? In other languages that use generics, you don't even have to do this. If it were C++ or Java, you could just say T. And so what we can do here instead is let's get rid of num, and we're going to say constraint.ordered. You do need to manually import this into your project, but it's golang.org/x/exp/constraints. What this is basically they took care of all the dirty work that we just did ourselves. So all the signed int types, all the unsigned int, combine those into a union, float 32, 64, complex, and they even added a string at the end of all that. So you can concatenate strings. So awesome. And if we run that, yep, works as expected. So let's go back to the original example where we had int and float 64. okay, what if we have this function, we only care about ints and float64s, we really don't care about all that other stuff, that's fine. It's very common in Go for us to create our own type aliases. So user ID, int, so this is, user ID is just an alias for int. And this should work, right? We should be able to pass in a user ID into this function. So let's try that. A equals user ID 1, B equals user ID 2. And let's pass in A and B here. Well, my IDE is complaining and saying, yeah, that doesn't work. What does the compiler say? Yep, user ID does not implement that interface. So we add this squiggly thing here. I think it's a tilde, and that will solve the problem. So we run it, and yeah, it works. So basically this tilde allows you to use any type that is an alias for this underlying type. So now I'm going to go over a more sophisticated real life example of how you might use generics. In programming, there's 3 common functions that you run into: map, filter, and reduce. And I'm going to try to create a mapping function using generics in Go. So let's check that out. So with a mapping function, you have an input, which is an array of values. And then you have an output, which is a function that mutates those values. So I might say n times 2. And I expect the output to be an array 2, 4, and 6. So let's go ahead and try to implement this with generics. But first, we're just going to create a non-generic function for it. So we'll say func map values. We'll have values, which is an array of int for now. And then a function, we'll call it map func, which is a func that takes in an int and returns an int. And then in the end, we're going to return an int array. So we'll say var new values, array of int. We'll say for each value in that list of values we passed in, we'll say new value equals the mapped version of v, and then we'll add that to new values. Cool, and then in the end, we're just going to return new values. Awesome. So what we have here is a non-generic, just a standard version of the mapping function. So let's go ahead and just see if it works the way we expect it to. So we'll say result is map values, array of int 1, 2, 3, and we'll pass in a function, return n times 2. And let's go ahead and print this. So let's go ahead and see if this works how we expect it to. So yep, 2, 4, and 6, right? We're taking 1, 2, 3, n times 2. Let's make it times 3 now. 3, 6, 9. Let's make it times 5. 5, 10, 15. So yeah, it works exactly how we expect it to work. So once again, the problem though is that we can only pass in integers, right? If I try to make this float 64, let's make these unambiguously floats. And I want to make these floats as well, just across the board. It just doesn't work because it's only accepting integers. So again, let's turn this into a generic function. So I'm going to say T is constraints.ordered. So remember constraints.ordered, we have to import this. This is